So continuing from last day, Sean, we talked about applications of acceleration. Really what I wanted to say is, hey, where can we use this stuff? I tried to give you some, at least to my inner nerd, interesting questions. We looked a little bit about airport design. We said you can use this to calculate how long runways have to be, although we did say that runway, you'd probably triple the length just to build in a nice safety margin, because this would be having the plane back up so that its tail was sticking out off the pavement and its front wheels would be taking off right when they hit the end of the pavement, which is not the way you want to do things. We looked at RCMP crime investigation. I did say we had to fudge things a little bit, Mackenzie. This whole catching the sound of the skid for 1.2 seconds, that's a bit of a fluke. Later on this year, you will have enough physics that actually, just from the skid lengths themselves, you'll be able to calculate the minimum speed the person must have been going when they hit the brakes. But I got to give you some more stuff. But another great application of physics is playgrounds. So it says this. A child slides down a playground slide, accelerating from rest. I would probably underline the word from rest. Traveling 6 meters in 4.8 seconds. I also noticed that my units are good. I see meters, I see seconds. That's kind of nice. When they hit the ground, their legs bend 20 centimeters. Ding, 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 ding. I don't do physics with centimeters. 20 centimeters is how many meters? Now, the two most common conversions that you'll do this year will be kilometers per hour to meters per second, which is why we added that to our green sheet. But the other one is probably going to be centimeters to meters. So you can do the whole write down what they gave you conversion. But I'm going to pretend growing up in Canada, maybe you know how to go from centimeters to meters. 20 centimeters is how many meters? Can we do it in their head? 0.2. So all of us right now, cross out the 20 centimeters and replace it with a 0.2 meters. That will often be how I'll fix things in the question. I could rewrite the whole thing, but often if I see yucky units, I'll correct them in the question as the child stops. A says, how fast does the child hit the ground? B says, what's the child's acceleration in stopping? So we're sliding down a slide, and then we're hitting the ground. I'm going to say that again because it's important. We're sliding down a slide, and then we're hitting the ground. I'm going to say it one more time. We're sliding down the slide, and then we're hitting the ground. Morgan, I'm going to argue, I think this question has two parts. On the slide and on the ground. So here's what I'm going to do. Slide. Nice typing, nice writing, Mr. Duke. Ground. Anything that I know that's from the slide is going to go in the slide column. Anything that I know that's on the ground is going to go in the ground column. So before I even jump to the questions, I am going to start to list all of my data. Well, okay. What's A asking me to find? I know it's a velocity. My next question is always going to be, which one? Final or initial? Well, it depends. I think final at the bottom of the slide. That's how fast I hit the ground. So I'm going to write in the slide column, okay, let's read through the question. From rest. What's that tell me? What's zero? VI, slide or ground? Now we got to be even fussier. Are we starting on the slide from rest? Okay, so VI 0 goes in this column. See how we put all that together? Good thinking. I keep reading. By the way, the word accelerating is in front of the word from rest, but I don't think that's the accelerating. VI is 0 from rest, okay? I think they threw that word accelerating there to try and trick me, but I can figure this out. I see a 6.00. Louisa, what are the units next to that 6.00? So that makes it a acceleration? Nope. Velocity? Nope. Time? Nope. Help me out, folks. What must it be? It's got to be a D. I keep reading. I see a 4.8. What are the units next to that 4.8? Time. Okay, seconds time. And that's still on the slide? How many things have I written down? 3. I can find the fourth. I'm looking for an equation that has a VI, and just like that, this now has become part A. So I'll put a little part A there, because I can solve this. I got a VF, a VI, a D, and a T. There's only one equation that works for. Which one? I'll give you a hint. I don't have the acceleration, so don't read me anything that's got an A in it. Which equation, my angels? Ibrahim, loud and proud. What?
E equals bracket VI plus VF bracket T.
Okay. Are any of these zeros? What? So, yoink. Ibrahim, what's 0 plus 5? What's 0 plus 10? What's 0 plus a million? What's 0 plus VF? Just plain old VF. Yes? In other words, the fact that it's 0, Louisa, I can modify the equation to just VFT over 2. I went 0 plus VF is VF, and now I don't need a bracket because there's only one thing in the brackets, and multiply. What are we trying to find? How would I get the VF by itself? And? Divide by T and something else. Because there's not just a T on the same side as the VF, there's something else there too. I totally agree we would divide by T, but isn't there a 2? Well, what's the T doing to the VF on the right-hand side? This 2 is multiplying? On the bottom? What? I will move the 2 over then. Okay, so here's what I would say. I got this written here. I would say to myself, I'll change colors so it's easier. I would cross out the 2 and say times by 2. Cross out the T and say divide by T. And so my new equation, VF equals 2D over T. Okay. Louisa, coming back to you, what was the distance? Yep. Divided by 4.8. How fast do we hit the ground at? 2.5? Meters per second squared, I would take a half mark off. Why isn't it meters per second squared? Because what's meters per second squared a measure of? Acceleration. And again, as someone who hates memorizing, if I tell you something is worth memorizing, it's really worth memorizing. It's worth committing the units to memory. Now, again, you don't need to chant them to yourself 150 times. You should start to memorize them as you do the homework. But if you notice in a week or so you're still getting units confused, then write them out on a piece of paper a couple hundred times or chant them to yourself a couple hundred times and they'll stick. So what was it, 2.5? Even? Meters per second. Okay. Cool. Aisha, what's part B want me to find? I think that's on the ground. So I'm going to make a little note here. B, and definitely A equals question mark, yes? Now, I have to be very careful. I'm not going to be using numbers from the slide. So, what do I know about the ground here? I'll give you a hint. That tells me something. Something 0. Yeah, what's 0? VF is 0. Okay. What else haven't I used that this question gave me? Yeah. How many things, Ethan, have I written down? How many do I need? Uh-oh. Now I'll pause and see who can see what I can say. Hannah has a look on her eye. What are you thinking, Hannah? The 2.5 on the slide question, the final velocity at the bottom of the slide, isn't that the initial velocity you hit the ground with? Hannah, my joy, that was worth a candy. That little bit right there, because there are a couple of questions in the homework. I think question number 2, for example, you're going to use your answer from part A to find part B. I'm going from memory, but there are going to be some questions in the homework, Justin, where I don't give you enough to straight plug and chug. You'll have to use one of your prior answers to find the next answer. Okay? Hannah, which equation? Oh, I was so proud of that, Mr. Dewitt. Yeah, we're going to bring it home, Hannah. Which equation? Stop. Can you, in your head, without reading the original equation to me, get the A by itself in your head and read to me the new and improved equation? Yes, it is VF squared equals VI squared plus 2AD. Can you get the A by itself? And if you can't, I'm okay with that. But this is what I'm going to nudge you towards, okay? Knock me out. See if you can do it. Somebody at the door? Hang on, we'll pause for a second. You were right, Hannah. You were right, but I'll talk you through the thinking for everybody else. What's going to drop down like a domino? So I tend to write that down first. Then I tend to do the adding and subtracting stuff. And that leaves behind a 2AD. I want the A by itself to get rid of the 2 and the D since they're timesing. I'm going to... There you go. Zero squared minus 2.5 squared all over 2 times 0.2. I'm going to insist all of you try this one on your calculator because this seems to be the equation kids botch typing in the most. By the way, who has a Casio calculator? And it's one of the newer ones, so not one of the ones that has the dark black color, but it's kind of a gray-y color. Show me yours, Justin, please. Face me. Show me the face. Yeah, that'll work. I'm going to borrow it for a second. So, tricks of the trade for those who have the nicer Casios that look like this. They have orange buttons on them. That's honestly how I recognize them. So if your Casio has an orange button, okay? Is this a fraction? Say yes. What you can hit on your calculator is this fraction button, which is right beneath the ABS or the calc button, right there. And if you do that on your screen, you'll actually get a top and a bottom because yours has a 2-line display. And so whenever I say brackets around the top, you can actually skip that step because your calculator knows what's on the top and your calculator knows what's on the bottom. And you can feel free to use that for the rest of the year if you want to. Those of us that are schlepping with the older calculators, is this a fraction? Everybody say yes. More than one thing on the top, Mackenzie? Yeah, brackets around the top. More than one thing on the bottom? Brackets around the bottom. So for me to type this in, it's going to look like this. Zero squared minus 2.5 squared. Close off the top. So I did an open bracket, close bracket. Those of you that have that fraction button, though, the new Casios especially, try that. It's actually a really nice display. I kind of like that. I figure in about 5 years, most calculators will have that, and I'll stop doing my little rant about top and bottom. You'll just be able to see the top and bottom. Divided by bracket around the bottom, 2 times 0.2. Why do you get a negative answer? Should I get a negative answer? Or does that scare me? When I hit the ground, am I speeding up or slowing down? Oh. How would I show slowing down for acceleration? Negative. Okay. Negative 15.6 meters per second squared. So when you're working on this homework, just at a glance, like question number 2, although it wants you to find time, I think you're going to have to find acceleration first. As a hint. There's a few like that in what I assigned. Let me pause the video for a second. Quick survey. How many of you ever heard the term G-forces before? Okay. Bad physics. G's are not a force, they're an acceleration. And so you're going to hear me for the rest of the year. I'll just talk about G's. I won't add the word forces because it's not a force, and you'll learn the difference later on this year. It's an acceleration. But we're going to talk about free fall. Near the Earth, in a vacuum, if we ignore air resistance, objects all fall to the Earth with the same acceleration, regardless of their mass. What that means is, if there's no air resistance, a feather will fall, will accelerate at the same rate as a bowling ball. That's true. Colby's giving me a skeptical look. Put your pencils down and look up. Everything in a vacuum, Hannah, accelerates at the same rate. And because it's accelerating under the Earth's gravity, we use a lowercase g to represent the acceleration due to gravity. Later on, you'll learn we actually call this the gravitational field strength of the Earth. G on the Earth is, anybody know? That's 1G. The negative tells you downwards. If you don't care about direction, if you just want to know how big, 9.8. Okay. In fact, people often talk about G forces. They really should be talking about G accelerations. It's not a force. And so I will often just say, how many G's? And not use the word force. I'll expect you to clue in. We're talking about an acceleration. So 1G, the negative means down, but in terms of magnitude, Maddie, how big is 1G? Just read that to me. So it's exactly 9.8. Or what nice number, right? What nice round number is that really close to? If you're trying to do math in your head. Like if you're standing in line at an amusement park and you want to figure out how fast you'll be traveling at the bottom of the roller coaster, it can be done. And I think it just adds to the experience of standing in line. 2 G's is exactly 19.6. Or really close to what? 20. Remember the slide question that we did? I think the acceleration coming to a stop was 15 point something. You know what? About 1.5 G's. Ish. 6 G's is exactly, what's 6 times 9.8? It's going to be a little less than 60. Calculator, go. Come on, somebody. What's 6 times 9.8? 58.8? Or approximately 60. Outside of a vacuum, air resistance can lower G if you're in free fall. But we are going to ignore air resistance almost all the time. Air resistance is a very, very difficult force to work with. How many of you have ever stuck your hand out of the window of a moving car? And then how many of you have done the fly it, where you kind of start like that and you turn it to a wing and it gets pushed up and you turn I encourage you, if you're not driving and you're not on a busy freeway with cars next to you, to try this. One of the things you'll notice is as you speed up, what happens to the force of air resistance? Bigger, smaller, or stays the same? Gets bigger. Gets bigger. As you slow down, air resistance gets smaller. And you also notice as you turn your hand so that you expose less area to the wind, air resistance can get bigger or smaller. If you expose more area, it gets bigger. If you expose less air, it gets smaller. The fact that air resistance is a changing force, you really need calculus to deal with it properly. So we'll touch on it a couple of times. I'll go off on these tangents. But for the most part, we're going to be in a magic physics world where there is no air resistance because it makes the math nicer. And you know what? As long as we're always talking about something like this, the air resistance on this won't play a big part anyways. So you can imagine whenever we're dropping an object, I'm talking about bowling balls or boulders. I'm not talking about a piece of paper or a feather. Okay? Human beings can survive up to 25 Gs in most situations without dying. But anything over 10 Gs will often break ribs, will break bones, etc. So if you are experiencing, for example, 10 Gs, all of you right now are experiencing 1 G, and you're used to that. That's what you feel as your weight. So if you're experiencing 10 Gs, that's like 9 people are dogpiling on you. That would be like 9 people were dogpiling on you. If you are experiencing 12 Gs, that would be like, what's 12 take away 1, Ibrahim? 11 people dogpiling on you. If you're experiencing 3 Gs, what's 3 take away 1? It's like 2 of yourself dogpiling on you. The math works just fine. So if you're looking for an analogy, 25 Gs, which I said was what people can tend to survive, that's like 24 people dogpiling on you. Yes, that would break bones. In fact, right around 10 Gs, 9 people dogpiling on you, that's where your ribcage would start to say, it's not good. Playland, the ride with the highest Gs, but 4. Which ride is that? If you take Physics 12, we'll do a field trip to Playland in May, and we'll go on the rides with accelerometers, and you'll get to find out. How do we know? Turn the page. How do we know that human beings can survive 25 Gs? Well, this is I'd like to introduce you to one of my nerd heroes, Colonel John Stapp. Colonel John Stapp in the 1950s was in charge of the Air Force's safety programs for the U.S. Air Force. Jets had just been invented, and the question was asked, is it even worth putting an ejection seat on jets, or will ejecting at that speed kill you anyways, in which case we shouldn't even give the pilots a chance, the option of bailing out. We should force them to at least try and land the plane, because maybe that's better for their survival. That was the question that needed to be asked back then. So Colonel John Stapp ran a team that investigated this, except he did not feel comfortable asking his team members to volunteer for the experiments. He volunteered himself, and he put his life at risk many, many, many times. So, read along with me. It says this. Air Force Dr. Colonel John Stapp was involved in designing and testing ejection seats for jet fighter pilots. He rode a rocket sled that ran on a special track, and he was subjected to 15 Gs for 0.6 seconds and a peak of 22 Gs during this March 9th test. So this photo here, he's pulling 22 Gs. His maximum is right here. His rocket sled was traveling at 0.9 times the speed of sound, which we call Mach 0.9. Mach 1 is 1 times the speed of sound. Mach 2 is 2 times the speed of sound. Speed of sound is about 300 meters per second. If it came to a stop in 0.68 seconds, how many Gs did he experience? So when I'm asking you to find how many Gs, what I'm really asking you to find is that, and then we'll divide that answer by 9.8 to see how many Gs fit into it. Everybody underline those 2 words. What does the phrase "a stop" tell me? Something 0. Yeah, what's 0? Be final? What's that 0.68? Now, V initial is 300 meters per second. Come on, you kind of want to know the answer now, don't you? I'm looking for an equation that has an A, a T, a VI, and a VF in it. There is one. Now, before you read it out, If by the end of this week you still can't find the equations, you need to come in for a flex block, or you need to come in after school and I can walk you through all this. But you have to, by the end of this week, you have to be able to find the correct equation. You don't have to be able to rewrite it yet. That'll be by the end of next week. But for now, Ethan, you were reading to me, yeah? Get the A by itself for me, please. What's going to drop down like a domino? Yep. 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 VF equals VI plus AT, and if you need to write that down, go ahead and then put a little dot above the A, move everything over, subtract, and then divide, reverse bedmass, and there we go. Let's go here. Oh, by the way, is he speeding up or slowing down? Am I expecting a positive or a negative acceleration here? Negative. 0 minus 300 divided by 0.68. Zero minus 300. It's a fraction. Brackets around the top. No need for brackets around the bottom. This probably won't work out evenly because I'm using actual numbers, and so I didn't fake them to make them work out evenly. This will be a yucky decimal. You get negative 440. That there? Let's go to 3 sig figs. Negative 441 meters per second squared. How do I convert acceleration in meters per second squared to G's? Hannah? Do something with the 9.8. How? What? I'm really asking how many 9.8s fit into there. I think I divide. Okay? So I'm going to go like this. G apostrophe S is going to be negative 441 divided by 9.8. When I'm using the 9.8 just as G, I don't include the negative. I just want to know how many 9.8s fit into there. What do you get? Maddie, what'd you get? Yep. And the units for G's are G's. He experienced the equivalent of 44 people dogpiling on him. The negative tells you that he was slowing down. Okay. Sort of. I'm going to show you the video shortly. He also exposed his face to 940 kilometer an hour winds in another test, because the other question is, okay, you may be able to survive the G-forces, but what will the wind at that speed do to naked skin if pilots are ejecting up there? If it rips all their skin and all their eyes and face off, again, then it's not worth putting an ejection seat in. Then we may as well try and force these pilots to try and land the plane, even if they're going to crash and die. That's better odds than dying for sure by ejecting. This was the thinking at the time. So he was the one, and then once he did some of the tests, a few of his assistants also did some of the tests. Put your pencils down, look up.